Thank you so very much. Can you hear me? So I'm David A. Wheeler. I work at the Linux Foundation, and I'm going to see if pushing this button will do any good for me. All right. Oh, good. All right. Always good for a first start. So just want to know, I've been working in developing secure software for decades, but mainframes have traditionally really not been my expertise. That said, hopefully everybody understands that security has become a very big topic. I mean, security is not new to the mainframe world, but it's become increasingly a concern across all of IT. And we've got just some very things about SolarWinds and Heartbleed. Got a reference to something called the Backstabber's Knife Collection, which examines supply chain attacks over various ecosystems. But as I said, working in security a long time, not really a mainframe person. So I asked various folks before I came here, hey, tell me more about what's going on in the mainframe world. And I'm not going to walk through all of this slide, but the comments I got back was, hey, special, different hardware, machines like the IBM Z family, lots of focus on RAS, reliability, availability, serviceability. Not all, but many of these systems are using EBCDIC. I'm so sorry. A lot of big endian, which leads to porting fund. I know what big endian is. I write code to try to avoid problems. Lots of other developers don't. What's a big endian system? Various operating systems, supporting various capabilities. In a lot of cases, not directly to the internet, not even directly necessarily exposed to data from it. I mean, yes, data passes through. That has some interesting security ramifications. So based on what I learned and talking to folks, there's some interesting things I immediately noticed right away. In general, across all of the IT space, buffer overflows, various other kinds of memory safety problems are a big problem in the software industry. Particularly, you'll hear things like Microsoft and Chrome both are reporting 70% of their vulnerabilities are memory safety problems. So, oh, hey, this maybe won't be so bad. A lot of these mainframe programs are written in COBOL. COBOL has built-in protections for, checking subscript. Oh, wait, you can turn it off. Oh, look, some folks recommend turning off. No, don't do that. Okay? If an app, now there's all sorts of awesome hardware for security on a lot of these mainframe systems. But if the app has malicious code within it or vulnerable code within it, think log4shell vulnerability and log4j. Is a mainframe potentially vulnerable still? Yes, it is, because the code's still running, and if it's vulnerable, it's still vulnerable. So it's still important to write secure software. It's still important to evaluate software before you bring it in. But now there's a rising problem in the industry today, and that is the glorious problem of software supply chain attacks. This is where attackers, instead of just attacking you operationally, exploit aspects of the supply chain of how software gets in. Sonatype reported last year there's a 650% increase year over year on supply chain attacks. Now, I don't mean just, hey, someone's intentionally modifying code and making it malicious. I mean, that does happen. That's a concern. But most attacks, supply chain attacks, aren't like that. Okay, and we'll talk a moment what they are instead. That said, obviously, supply chain, big problem. So why is that happening, and what's the rationale? Well, Anisa had an interesting response to this. What's interesting is that increasingly, not everywhere, but in some of the most important software, a lot of projects are starting to get the message. They're starting to improve the security of their systems. Most software developers don't know how to write secure software. I think that's terrible. We're working that. But for the projects where that's really important, they are starting to get that training, and they are starting to make improvements. But guess what? Attackers are going to attack the weakest link. And the weakest link, if the weakest link is the supply chain, well, that's where they're going to go. And so you have various things like the executive order put up by the US government. They want to know, well, what's in there so they can start to get a handle and understanding of the supply chain, of the components they're bringing in. So what are these kinds of supply chain attacks? Well, until I think it was last year, by far and away, the #1 supply chain attack is an attack called Typo Squatting. Okay? And this is where the attacker creates a whole bunch of variants of package names that are almost the right name. You know, we'll swap a 1 with an L, or an O and a 0, or an underscore with a dash. And we'll do that a lot. And you know, if you type in not quite the right name, you'll get the software, but not the software you wanted. This is by far and away the most common supply chain attack on open source software from 2015 all the way to 2019. And you know, it's now number 2 because another one popped up, but it's still one of the most common kinds of attacks. How do you counter this? You double check the name. It's not even that hard, but knowing that that's an issue is really the key here. What's the most common kinds of open source supply chain attacks today? And that one right now is the glory of dependency confusion. And this is where this is a supply chain attack on some package managers. And the idea here is that the attacker creates a public version with a name of a package that happens to be the same of an internal package you're using. And through some kind of trickery, convinces you to use the public one instead of the one in your internal system. Now, there's lots of ways that people can figure out the names of your internal packages, and there are lots of tricks to convince you to use that instead. You know, hey, I'll make a public one, and you know, that name's not used in public, and it's version 999. Wow, it must be the latest version. Okay? And they'll convince you to use that instead. Now, this is relatively novel. You can see instances before, but really was popularized in 2021. And here the fundamental issue here is that organizations thought that, oh, I'm using an internal registry, that'll automatically make me secure. No, I mean, it can help you, but if it's used wrongly, it can make things worse. So I'm not saying don't have an internal registry, but you've got to use it smartly. You've got to make sure that when you bring in software, you're bringing in the right software, the software you intended, okay? And these are right now the bigger problems is not that a well-known open source project is subverted. The bigger problem is you didn't bring that one in, even though you thought you did. And this brings up a more general problem. The US executive order certainly raises this issue that most projects, most organizations really don't know what's in their software. You know, I've got a container. What's in it? I have no idea. And no one else does, including the person who claimed to have created the container. Because they brought in other stuff, and that transitive closure, if you're familiar with the math term, basically tiers and tiers and tiers and tiers makes it very, very hard to answer that question. So I want to talk real briefly here about an organization called the Open Source Security Foundation, the Openssf. It's a sibling foundation. So it's another foundation within the Linux Foundation. Its purpose is to collaborate to secure the open source ecosystem. And that includes open source that runs on mainframes, because that's part of the open source ecosystem. It was formally started in 2020, but switched over. But during pandemics, trying to deal with funding was a little more challenging, some of you may understand. So we finally switched over to, I think, a more stable funding model in 2021, once people had a better understanding of what the heck's going on regarding the pandemic. I'm not going to go too much into the org chart here. My main point is that, like most Linux foundations, there's a governing board that decides funding. There's a TAC, a Technical Advisory Committee, that makes the higher level technical decisions. But most of the work happens really within working groups and associated projects and the projects within those working groups. And those working groups are focused on different areas, anywhere from best practices to supply chain integrity to how to handle vulnerability disclosures. So one of the more recent things that the Openssf released is something called a concise guide for developing more secure software. We often get, well, how do I make more secure software? Well, start here. Here's your start button. Now, you'll notice in the start button very quickly what it does is it points you off to other things, but that's okay. This is a place to get started, because for a number of folks, they don't know how to get started. And I haven't listed all of them, but the first thing is, hey, get MFA tokens, because some attackers do try to break into user developer accounts and then try to insert malicious code through controlling those developers' accounts. MFA tokens are a really strong countermeasure against that. They don't cost much. It doesn't take much to start using them. Another one is learning about secure software development. I'll talk a little bit more, but we have a free course using a combination of tools in your CI pipeline. When you make a change, that should run through a battery of tests and examinations, and that should include tools to look for vulnerabilities. They will not find everything. They will make reports that are false positives in your situations, but you still need to use some tools, and you need to have some education so you know how to understand what the tools say. Evaluate software, I'll talk about that next. You need to be prepared to do rapid updates. In spite of everything, there will be vulnerabilities found. So we need to be prepared to update rapidly. So use package managers and other automated tools to manage your dependencies. Implement automated tests, in particular, negative testing. I've seen so many test suites where they test really hard that the software does what it's supposed to do. Does it reject things it's supposed to reject? No? Then you only have half your tests, or at least you only cover half the testing issue. You know, if unauthorized users can delete everything, perhaps that's a problem. Okay? But if you didn't test, how do you know? Monitor known vulnerabilities in your direct and indirect dependencies and keep them reasonably up to date. No, you don't have to update for every single change, but if you're too far behind and a vulnerability is found, the current version is going to get updated. If it takes you 3 years to update to that version, you have a 3-year problem. Okay? And then there's other things like the Openssf Best Practices Badge and Scorecards, which can help you understand, if you're running, for those open source projects, what you need to do. How do you evaluate open source software? Before you bring it in, or it's already in, but you're trying to do some risk management. So there's this concise guide that tries to help you figure out, what are questions you should ask, and although I'm not showing here some more detail about how could you estimate the answers to those questions, and the URLs there on the bottom there. Step one, do you have to have added it all? If you've already got the code for that, why don't you just use it instead of adding yet another package? Are you evaluating the intended version? I mentioned things like typo squatting and so on. So I mentioned earlier, there's a free course on how to develop secure software. Most software developers have never been taught how to develop secure software. That's a failing in our educational system. And I say that as someone who actually teaches courses like this at a university, but it is a general failing that we're not teaching the developers. We're getting more secure software than we deserve, okay? So we need to fix this. So the Openssf released this course. You can blame me, I'm the primary author. On average, take about 16 hours to go through. And it teaches the fundamentals of developing secure software, whether or not it's open source. It does include a module on how to evaluate open source before you bring it in, because everyone does that, whether you develop closed or open source. And you can get a free certificate, and there's a link there. You can learn more information. There's lots and lots of other materials available from the Openssf. I wish I had time to go through them all. But if you are developing an open source software project, involved in some way, I encourage you, please get an Openssf Best Practices Badge. It used to be called the CII Best Practices Badge. The logo still has the old name. We will fix the logo eventually. But it's moved over now to the Openssf, but it's going strong. We have over 5,000 participating projects now, and working to meet various goals of passing silver and gold. But even a passing badge is actually an achievement, and you want to see projects using, having at least a passing badge. Openssf Scorecards. This is an entirely automated way to measure open source projects. So you can just take, what's the status on things that we can automatically measure. Really, really helpful for, again, hey, I'm using a whole bunch of open source. Which ones seem to be a little more concerning? Which ones seem to be less concerning? We're working on something called SALSA, Supply Chain Levels for software artifacts, which identifies various ways to secure the builds And basically, how do we make sure that the software that gets out that you end up with is the software that the developers intended. And finally, a guide to coordinated vulnerability disclosure. And this is a guide for open source software projects. Ideally, software would never have vulnerabilities. And there's a lot of steps you can do to greatly reduce that. But mistakes happen. They may slip through your reviews, your tools, and everything else. And so it's really important for open source projects to be prepared to deal with a vulnerability report before it shows up. By the way, I also lead that best practices badge. And one of its requirements is you basically have to tell people how to report vulnerabilities. That is I believe that is the #1 most common missing item when people first start trying to get that badge, is they don't tell people how to report vulnerabilities. You don't want to wait to figure out how to report and process a vulnerability when you get the first report. Okay? Now you got to spend a lot of time to figure out process and who does what and how do we do this. You need to be ready to handle it quickly. And so you need to be prepared ahead of time. All right, so basic bottom line is, if you're interested in open source software security, please get involved. If you are, there's a huge number of organizations, projects that are involved. I mentioned Openssf already. SigStore is one I haven't mentioned as much about, but this is a new approach to performing digital signatures for signing them and later for verifying them. We've had digital signatures for decades, but within a rounding error, they're not used very much in industry. They are used in specific cases, hooray for that, but there's a lot of cases where they'd be useful, where they're not used. People find them too hard to deal with, particularly too hard to verify. I see a certain digital signature, is this the right one? How can I figure out what the public key is that corresponds? We need a better system so that's much easier to use. So SigStore is trying to make that much, much easier. There's various other organizations. SPDX was mentioned. That's a specification for explaining what's called software bill of materials. Software bill of materials is fundamentally what's in this software. And why would a recipient, a user, want that? Because they want to have confidence that the software in there is less likely to have vulnerabilities that are going to impact them as users. And so, historically, we just assume that organizations who release software were always keeping software up to date. That's a terrible assumption. Turns out not to be true, okay? So what the US government and many other users are basically saying is, hey, wait a minute, this lack of transparency is a real problem. We want to find out what's in it, not because we're nosy, but because we have concerns that there may be a lot of known vulnerabilities in the components that software is built on. And the best way to answer the question, whether or not that's true, is to find out what's in it. And that's if you're interested in improving open source software and security in general. And I've also mentioned some specific projects which you can apply to help you develop either more secure software in general, closed or open source software, or how to evaluate and improve the open source software itself. And with that, any question? I think I have time for one question if you want. No? All right. I'm actually going to stick around after this, so I would be delighted to talk with any and all of you about any of this stuff. So with that, thank you very much.